There we are. All right, everyone, we're going to do an impromptu live stream today. This is going to be a members only live stream because all live streams where I do case studies now are going to be for members only. Let me go over here and turn off some fans. The new microphone that I'm using, it's got a little bit of a high gain, and it picks up fans pretty easily. But what do you expect for $30? I'm poor, but as soon as I get enough members, I'll be able to buy a better microphone. In the meantime, let's go over some equipment and let's go over what the vehicle's here for. So we have a 2015 Crosstrek, and she has on the clock 54,000 miles. Hasn't even had its first tune-up yet. Customer's concern is the AC does not blow cold. Now, just putting my hand in front of here, I do have plenty of vent speed, or I do have plenty of velocity coming out of there. I don't have a blower motor problem. Obviously, something performance-wise on the AC side is not working, and that's what I hope to figure out today. The equipment that I will be sticking with here is I have a digital temperature gauge here by Power Probe. I prefer this over analog gauges, which work just fine. I mean, I have them. I just use them for other things now. Oh. That's what you got. That's what you got. So we're going to need a temperature gauge. I'm going to be using the digital ones here because I have two digital sensors that are wireless, and they'll talk to this guy right here, and I can keep this with me on the side as I work on the engine bay side, and I can see if I made a change here to the vent temperature. That's going to be nice. I also have a wire probe to my Curian voltmeter, which is nice. I'll be able to snake this all the way down into the evaporator core and get a temperature reading from the actual evaporator core. We have our basic IR gun. Point the dot at something, get a reading. We have thermal imager. This is the FLIR 1 Pro version. It's more in the $300 range. I prefer this one, the Pro version, just because it has a higher resolution. It has been worth it. It pays for itself within 1 or 2 uses. I got a test light. Now I have a high condensate test light, and I have an LED test light here. Okay. Not a big fan of these LED ones, okay, because these are more or less just probes. I want something that can actually pull down the circuit a little bit, so that's why I keep my old analog ones. I heard my... There it is. All right, I didn't lose Cal. That's good. We use our UV light. I'm a big fan of OptiPro UV Plus. This is a UV light that is tuned to AC. All right, there are a lot of UV lights on the market, and a lot of them do not illuminate the chemicals in the vehicle as well because that UV light is not tuned to the frequency that it needs to be. More on that in another video. We do need our yellow lenses, our sexy specs to make this work better. I will be using that. And lastly, I have an anometer here that is going to measure wind speed. Wind speed is going to be very, very important. I use wind speed to measure the amount of air that's coming out of each vent. If I think I have a restricted or collapsed conduit, I use wind speed to measure my 2 fans to see if my fans are not blowing efficiently enough in order to cool down the condenser. So let's begin now. Turn on sensor 1 and get her in the car. All right, so first off is first rule of diagnostics: verify customer's concern. Hopefully the light on my probe. All right, now the battery. I didn't turn the battery on. All right, so should be updating very soon. If not, I'll use my second probe. Okay, and hey, they're both talking, but they're not rocking. There we go. Reset fixes it. Okay, so with two probes plugged in, it's just going to cycle back and forth. So sensor 1, 75 degrees. All right, let's slow it down. Slow it down, baby. Sensor 1, 67. Sensor 2 is 73. We would expect the driver's side to get a little bit warmer as everything starts out here on the passenger side. So it's very normal to see a 5 to 7 degree difference out of the farthest vent away. I only care about the center vent, so I'm just going to turn off number 2 for right now. Keep it simple. 65 degrees. It's on fan speed 2. Having a lower fan speed on your evaporator core during your diagnostics is going to help you see any changes you make to your AC system performance-wise in the engine bay. If you have the fan speed blowing as fast as it can across the evaporator, it's not giving the evaporator core enough time to cool down. You can do this yourself in your own car. Put your temperature gauge into the vent, put your fan speed on the lowest setting, put your AC as low as it'll go, and you're going to notice that the air coming out of there is going to be a lot colder than the air coming out of it with the fan speed on high. It's just all about the fan taking away as much heat as it can from the evaporator core. Okay, now before I jump into anything crazy, let's determine what kind of AC system I have here. Okay, this AC system right here, this appears to be a manual controlled AC system. This doesn't have any kind of auto on it, or maybe it does. Okay, we do have auto. We have an auto feature right here, and auto. Okay, so this is important to know. We're using an auto AC system here. This is not a manual AC system. If this was a manual AC system, then there would be less circuits to check, but because we're checking because we have an auto AC system, then we have to also take into fact that we have an AC control module. Because we have an AC control module, we're going to want to go ahead and scan for codes. Now, we're going to be using SM4 right here. And this vehicle is at the transition point where it used the old SM3 system and it uses the new SM4 system. Always choose the highest tier unless your repair manual says otherwise. And I've never encountered that yet. Going to do an all scan. And again, I haven't seen anything on this car, so whatever I find, you're going to find it with me at the same time. While that's happening, let me get my coffee. Well, it's taken a little while to scan, which means it found some codes. let's go over some other stuff while we wait. That's kind of boring. We'll be using an AC machine to verify pressures when that time comes. We can look over here in the engine bay. We do have a brand new aftermarket compressor. We have a brand new thermal expansion valve there. Can we see our fans? Okay. I can see both fans running. Let me get a light. Yeah. I got both fans spinning. I can definitely see that this fan right here on the driver's side, that motor looks brand new. Okay. Oh, we're done scanning. Okay, tire pressure, battery control on the body control problems. I don't see any AC problems. I'm not going to worry about this stuff. This is more than likely a result of the battery being disconnected or the battery just being on its way out. I'm going to go to each system, air conditioning. Let's go to data monitor and see what PIDs we have here to use. So I have an in-vehicle temp sensor, says it's 81 degrees. I'm going to agree with that. Within 5 degrees. Yep. Oh, to explain. On the power probe, the top number is using this sensor right here, so it's reading whatever ambient temperature, whatever it reads cabin temperature if it was inside the cabin, but it's only reading outside temperature because it's outside the car. Okay. Sun load sensor. Okay, we can see our coolant, 204 degrees. That's good. If our vehicle was overheating, the AC compressor is going to get commanded off. Okay, we can look at our positions of our mode doors. We can look at the command temperature. Our ambient temperature is reading correctly. Tells us where everything is at. We got engine speed. We have an evaporator temperature of 53 degrees. That should be more in the mid 30s. So we do have an efficiency problem here. I think with that information, I am content to do a visual inspection on my compressor now. All right, let's see if our clutch engages and disengages. I have the fortunate opportunity, I'm fortunate that I can actually unplug my compressor here. All right, plug it in. Cool. All right, I'm happy with the circuit. If you weren't happy with that circuit, let me show you a trick on Subarus that I really like. Let me move this because it's in my way already. I'm going to hit stop on this so I don't make it mad. We're going to turn our car off. And on this model, we're going to take a fuse, take a 10 amp fuse, and right here, we're going to plug it in. Okay, this is going to put the vehicle in what's called diagnostic check mode. Let me get you an overlay so you can see what's going on. So this right here, this is our big relay box right here. This little one right here, you'll notice that that slot that I'm using for the fuse, it's got a slash through it. It's because I don't want you to know what it is. This switch, this tactic is for factory use only. When the vehicles are all put together, they verify that they put the electronics together correctly. We're going to go key on, engine off. Sorry, this lady has like an eucalyptus air freshener in here and it's gagging me. Okay. So we're going to be looking for some conditions here in the car. Condition number one is we're going to see if our cooling fans here are switching high-low, high-low. And they are. I can hear them changing pitch as I get faster and faster. I put my hand in front of them. Yeah. Maybe a little bit of a temperature change. Christmas trees. I'll get you the right clips. Okay, that fan is feeling a little bit on the weak side. How's this one? Oh, yeah. Let's go ahead and set up our test equipment. Okay. All right. So I'm looking at a peak of 1,800 feet per minute. Or not feet per minute, FPM. It's, what is this on? It's on flow velocity. I wanted a, it's supposed to be on CFM, I'm sorry. Oh, I'm not going to mess with it. I'll work with what I have. Let's compare it to the other one now. Interesting. Okay. Get a retest and reposition. Okay, that was driver. I'm going to look at passenger again. Okay, this looks better now. I'm liking that better. Okay, here's what I'm noticing. I'm going to try and, I first had my anemometer too much in the the fan position over here, so I was getting contaminated readings. I'm just going to put it right here on the side. Looks like I'm getting them 1350. And then it's falling down to about 800. It's cycling on and off. That's what it's supposed to. Okay, now I'm on the driver's side. Okay, I'm holding it backwards. I gotta switch hands. It's very interesting that this fan is not juicing like it should. Okay, there we go. We got some stable readings now. 1350. Why they were better over here, I'm presuming mainly because of the fact that I'm running out of battery juice. This is very possible. Bring over here. There we go. Reinspect. I do a stop. New. Just because I did so much messing around, I'd rather start with a fresh one. Alright, so the extra voltage is helping a lot from the battery. On high, I got about 1500. And low, I got about 750. I can live with that. Let's look at passenger. Okay, passenger side is a little bit on the weaker side by a couple hundred each oscillation. If you have one of these anemometers, it's really important to never stop the blade with your finger. You can break the bearing, especially on the higher end ones. If you got a $10 one, do whatever you want with it. And there's a cover that goes on that. Don't lose it. Okay, I'm happy there. I don't need you. I don't want you. Go back to our car. Turn it off. Now, during that whole test, I noticed that my AC clutch was not cycling, and the AC clutch should have been cycling. If some of you didn't catch that and know about this test, that's going to give me an indication that we possibly have a low freon charge. Now let's get this fuse out of here. We don't need it anymore. And I want to now look at my static line pressures. So you have your running pressures and then you have static line pressures. Static line pressures means that the engine's been off for at least 10 minutes. All the pressures in the AC system have had a chance to equalize. An important note too is make sure your gauges are on the low setting here. That means that when somebody was done using the AC machine, the lines from the machine were recovered appropriately. If it was any different, then you're going to want to run a recovery cycle to make sure there's nothing in the lines, because I have had technicians use my advice and they forget to check this, and these lines are holding about 100 psi of charge. That means that there's freon in these lines, and that freon, when it's allowed to be introduced into here, one, you could be contaminating a system. Two, you could be temporarily fixing your problem because you gave it just enough of a charge to fix itself. All right, so these are tightened down. When you tighten them down, you should hear the lines get charged up with pressure. And let's come over here. Okay, so our outside temperature, let's verify what it is. Sorry. Whew. My outside temp right now is 87 degrees. My line pressure is 100. I'm going to say, yeah, there might be a little bit of a low charge on this. Let's look here for a service sticker. And right away, this is not a good sign. So let's look. The service sticker for an AC system should be somewhere on the inside of the hood, or it should be somewhere right here on the cowl. I am not seeing an AC sticker. I am not seeing an emission sticker, which would indicate that this vehicle has been in a collision, and when the hood got replaced and painted, they didn't move the stickers over. That sucks. But that's also good. It tells us the car's been in a collision. You can verify this with a Carfax. All right, water time. Let me get some water because I am not coughing into this microphone all day with you. What do I got? What do I got? Oh, all I have is this stuff. Yay. Kabuchi. All right, so do you all feel safe vacuuming down this system right now? Do you think that this could just be a low charge condition? Or do we want to collect any more evidence before we go in? Because I have actually seen some cars get fixed by doing an evacuation. So let's recap what we did. We verified what type of AC system we have. This is an auto AC system, which means it has an AC control module. We went to the computer. We did an all scan. We don't have a code for the AC control module. And then we went into all the PIDs and we made sure that the PIDs were looking normal or as expected. We looked at our cabin temperature, our ambient temperature, our request for cold air. Everything was giving us good feedback. And most importantly, we looked at our engine temperature, which is here reported as heater water temperature. That wasn't crazy hot. If your heater water is crazy hot, then the car will not give you an efficient AC because it's turning off the AC cycle here, trying to reduce the load on the engine, which would help cool the engine. We put the vehicle into a diag check mode, which allowed us to oscillate our fans from high, low, and we used an anemometer to record the amount of velocity that's coming out of each fan. We have about a 10% difference, I'll give it that, maybe 15 at the most, between the driver and the passenger. It's not horrific. It's not something that I'm going to go chasing down yet. The fact that each fan is turning high, low, tells me that my electrical circuits are working good. My relays are working good. I got to have something good in the harness, and there's no reason I should be going crazy with a voltmeter yet. Let's do a visual inspection with our UV light. I moved it over here. Take off these. Put on my yellows. Let's just take a peek. Nothing crazy. Looking under the hoses, looking around the hoses. Look for dark spots, look for wet spots. Whoa. Look at that. That thing's lit up like a friggin' Christmas tree. You can see it through the camera already. Move these hoses. Get in there, man. Yeah. Look at that neon. Well, I think we got to fix that leak before we do anything else. What do you say? So, let's see if we got anything else. Let's not get crazy yet. Yeah, the front's looking good. This is a new condenser, so I'm not going to see any rock chips in it. Let's go to our firewall. Got some fly poop. Nothing as grotesque as that one. So let's go ahead and start our recovery now. I am happy to recover this with all the information I've collected. And now I'm going to have to go to service data, and I'm going to have to figure out how much this system is supposed to hold. Wow. Sorry, this is what's been holding me back from doing so much live streams. I lost my voice about 2.5 weeks ago, and I am still having some really, really bad side effects from it. Where I'm talking, and then just all of a sudden, my whole throat goes dry. You can't see my stuff. You can't know my password. All right. Let's go to Subaru. Okay. Really? The browser's acting up. This is a 2015. HVAC general specification. Okay. Says this compressor setup is a 17,000 BTU. It's pretty weak sauce. Here in Texas, you need 20. Cooling capacity. There we go. Refrigerant says it takes 475 grams. All right, well, this is going. We'll check on you. Oh, okay, HVAC. Thanks for checking in, man. Yeah, the issue is the AC is not cooling efficiently. Here to see if somehow I can get you all checked in up here. I am looking for some sort of a better hood now. Believe me, I am. I thought this gorilla arm was going to do it, but it's obviously not. Hey, that's perfect. I like it. I'll take it. This coolant overflow reservoir just has a little clip. Older models have 2 10 mils. We just need it out of the way. Then down here is a 10 millimeter that I'll get with a box wrench. And of course, all my 10 mils are gone. All right, so our AC machine needs about another 4 minutes to completely suck this down and give me some sort of answer. I think I have some AC O-rings down here. Have to resort to using generic AC O-rings because there's a huge shortage on AC parts all year. So, folks, don't push your AC repairs until the last minute. We have compressors on back order. We have condensers on back order. O-rings on back order. Everyone's getting AC repair now because they drove their stuff into the ground. And when you do that at the wrong time of the year, everyone wants AC repair. So it's ridiculous. I did an AC repair and oh, what is this? I found an O-ring here in the engine bay. Yeah, I had a customer that was in one of my loaners for 4 weeks because we could not get an evaporator core. And it wasn't a new car. That was a new car. It was like a 2017 Outback. "30 seconds remaining." Hey, it's weighing everything it recovered right now, and now it's separating out the oil. This is what I really like about using an AC machine, an all-in-one, instead of using the old school method. Let me show you what that looks like. All right, so before we had an AC manifold gauge set. You had your two gauges up here, and you had your three lines out, high, low, and then this was your charge line. I haven't used this in over 15 years. And it doesn't even have hoses on it anymore because I've been using this for parts for other homemade stuff. If you have a shop and you're still using this to charge AC systems, folks, you're wrong. These machines are so inexpensive now, and they're so much more sophisticated at giving you. You have to use this. The only time I endorse one of these manifold gauge sets is if you're using a mobile version of the AC machine, okay? And my HVAC guys know what I'm talking about. That alone is still an expensive piece of equipment. It runs at about $1,500 minimum. That's not including this. Some of those HVAC guys have gauge sets that are worth $1,500. Okay, so we pulled 320 out of here. The system's supposed to be working at 475. We're talking in grams. I do everything in grams. I do pounds. So it pulled out 320 grams of Freon, and we're supposed to have 475. This is enough condition that I can now open up the system. And wouldn't you know, I lost my 10 mil already. Bloody hell. Aha. It was in my back pocket. Okay, lefty loosey. Oh, that was on there kind of tight too. On Subarus, this high side line is notorious for getting damaged from people installing batteries and from people servicing the AC line on the condenser because it's just at a funny angle, and there's a lot of other things that can interfere with your repair due to the angle. HVAC line, I had to move that low side you just saw. Oh, look at that. It's got piss all over the bolt. Come on. There we go. Yep. I know. See how I'm fighting with it already? It's just in a weird place. And it's real easy to start kinking it right here to manipulate it out. You actually want to cup this and you want to support this crimp. Too many times have I seen this crimp leak because people are trying to fight this line out of here. And for good reason. This line does put up a fight sometimes if you don't know what's going on. That is a lot of oil. And we got some dead pixies in there too. So what some folks don't know is whenever you get a new compressor, they come loaded up with oil to keep the insides from rusting, and you're supposed to pour that oil out unless the box says not to or your manual says not to. But on Subarus, they tell you dump the oil out of the compressor. All right. Check out my fitting. Checking out my O-ring. Folks, this is the original O-ring. No joke. There's the problem. I don't know. Hopefully you can see this. But one edge of this O-ring, it's going to be your left maybe. It's got a square edge on it, and the other side has a rounded edge. This O-ring here is as old as the vehicle. All right, that is the same one. Let's just double check it against this one for good measure. I like that OD of this one better. Okay, there's enough oil inside this line that I can just give it a courtesy wipe to make it go in smooth. I'm going to go down here. I'm going to wipe off where the O-ring lands in to make sure it's clean too. The rags that I'm using, I use these blue shop rags. They're a little bit more on the pricey side, but red rags leave too much lint. And I'm going to go ahead and take this whole line off. Again, I told you, this particular line is a butthead, and I don't want to break anything. Trying to maneuver it in. Okay, so the compressor has new O-rings on it with metal. This is not my compressor, by the way, so I'm just using whatever the last shot put in. I am going to reuse that O-ring that was on the compressor, yes, because it looked healthy, and it does show evidence that the O-ring was replaced. So that means that O-ring is not more than just 2 weeks, maybe tops old. I trust its integrity. A little tight. No, my wrench. Wait. Get some brake cleaner on that. I need to clean my area up. I'm tripping over everything. I'm also really tired. Okay, tight and tight. I got a new mount. See? Look at that. Boom. It holds my phone magnetically. So I don't, once I got it set up, I can just take it off. All right, so let's go ahead and do a recover. No, 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 no. Stop, 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 stop. Back. Okay. I'm okay. I'm going to opt not to do a leak test, and I'll explain why I don't do leak tests on AC machines. I don't do leak tests on AC machines because I know what it does. An AC leak test, after you've pulled down vacuum and the vacuum time has been expired, then it runs a leak test here. All it's looking for is a rate of change within 10 minutes of this needle. So if that needle moves, like, I think it has to go almost 10 inches of vacuum before it says leak test fail. If that's a really, really tiny leak, it could take all day for that to populate, or it may not even populate at all. And I have watched so many AC technicians base their diagnostics exclusively on that test, and it's because they don't know what it does. That leak test is only looking for so much leak over so much time. If you want to put your faith in it, go ahead, but I don't. I know that if I seal the system correctly, the system is sealed. I'll give it a 5 count. But if I don't see any deviation within 60 seconds, the system's sealed. If I have a repeat failure, this car is going to stay on the vacuum test overnight. I'll come back the next day. All right, let's put you back up here. I think I had you guys. Yeah. In the meantime, I'm going to run a test on that battery. Make sure it's okay. Every wire I'm touching today is tangled, and it's frustrating. Got left on the vacuum. I'll probably just kill it after this battery test is done. So far, we're just looking at a craftsmanship problem. I don't even know what the original concern was. The original concern, honestly, could have just been the system was low on Freon. This is very normal. A car, a vehicle AC system, all the components are sealed with bolts and O-rings. In some areas, like Texas, Arizona, Florida, really hot areas, these AC O-rings on the engine bay side, on the compressor side especially, they wear out quick and they will leak a percentage of their charge between 1 and 10% annually. So it is very normal for a car. This isn't just Subarus, this is all makes and models. For a car over 5 years of its life here in Texas to lose at least 30% of its charge just because the O-rings are blown out. It's just too hot here in Texas. You have to get your AC serviced every other year like this. And by that, I tell people, Let me evacuate the system, let me change the O-rings, let me vacuum test everything and make sure it's working efficiently. Because if you run a low charge too long, you'll burn your compressor up. All right. Okay, this is a stupid start battery, so it's got 550. Flooded. This is one of my favorite battery testers. A lot of people think that this tester does nothing but fail batteries on purpose. Do that. They just don't understand battery testers. This actually runs, this battery tester actually has a proper load cell in it, okay? And it'll load down the battery and it'll look to see how fast it recovers. All right? If the battery's chemistry, the electrolytes that are in the battery, if it can't rejuvenate itself, it means there's a problem with the plating in one of the cells, or there's a dead cell. This thing will figure it out. This thing will tell you. Is it worth $1,500? Hell yeah. Okay? Because I've seen too many of these other testers, the $100, $200, and $300 testers, just lie to customers. They're like, oh, good enough. No, this thing gives you a comprehensive test because it's actually running a program. It hits the battery. It's like gut checking it. Look at that. This car needs a battery. And it was replaced February 2021. I'm going to go ahead and do my charge now. Okay, so I'm going to do something based on my experience. I already saw a lot of oil drip out of these lines. I'm willing to bet that there's a ton of oil in this system, and I am not about to introduce any more oil. If I hear the compressor make any kind of noise, I'll shut down the system immediately. You can turn your system on, and if you hear something you don't like, turn it off, then put oil in. I'd rather do that than overcharge this thing with oil, because systems that are overcharged with oil, they take forever to clean out. I think I've had to do evacs and recharge like 10 times trying to pump all the oil out of a system. I'll be injecting all my Freon through the high side. And there was a lot of standing oil at that connection. Come on. Charge up, Bubby. You can do it. At 2 o'clock and wow, this place is a tombstone. This entire shop here is dead. Man, I can't believe how dead it is. Whew. Okay, we're coming up. I've been watching my charge too on my pressure gauges. I always look for anomalies to see if one side moves faster than the other. That can indicate that you have a possible clog in the system. But we're doing really good. It's just trying to get that last 10 grams in the system. So, yeah, we're almost there. Super. I'm not going to disconnect and I'm not going to evacuate my lines yet. I'm going to leave them hooked up. I want to check my line pressures. Okay. Gotta put our fan on high, temperature low, top vent. Should start seeing something come through. Need to give it some RPM, get everything through the system. Low side is really high over there. I think that compressor's shot. All right, let's come and inspect everything. We're only putting out 73 degrees. My high side, 190, okay-ish, but I'm more worried about my low side right here. My low side should be between 30 and 40 psi. The fact that it's hovering at 60 is giving me the indication this may not be sucking down or may not be sucking out all the juice out of the evaporator efficiently. This sometimes can take 5 minutes to equalize, but typically a rev up tune-up gets its butt in the right direction. This line is nice and cold. This line is getting warmed up. But again, 60 psi on my low side, I don't like it. And I'd like to see a little bit more on my high side, but if I got a low high side and a high low side, I could be looking at a compressor problem. The air is a little bit better. Again, I'm going to help the compressor by increasing RPM. Just get some things going. But if you can see my gauges right there, I'm going to do a snap throttle right now. I don't like that. I don't like that compressor. I don't like anything about this. Now let's go back to my gauges and let's talk about those really quick. So maybe you're thinking, turn down the fan too. Bet you that's blowing you in the balls. Okay, so if you were suspecting the condenser, the aftermarket condenser being a problem, we would have high side pressure going up. The fact that we don't have extreme high side pressure indicates that the fans in the condenser are doing its job. Why we're not getting a good enough low side, why the pressure on the low side is too high, well, that's just going to mean that the compressor is not sucking in enough efficiently. It might have bad vanes now because I did see some metal in the system. So this compressor could have kamikazed itself running on a low charge because the previous shop reused O-rings. So unfortunately, this customer is going to have to do one of two things: buy a compressor from my shop with warranty and go fight the other shop to warranty the entire job, or just pay me for diagnostics, go back to the shop and take my notes. But we're going to call that it. This is the problem. We found that this was a craftsmanship error from the other shop. They did not replace O-rings when they installed that new condenser, and more than likely they were reusing O-rings from all the other parts of the car because they don't have O-rings on hand, and they're using a generic fit kit, and they're not measuring anything out. It's really important. You have to get exact size O-rings. Even the one that I put in there, I just put that in there for quick diag. I don't have a parts counter today, and I'm doing this repair out of the fact that I want to shoot a video. So I doubt that this customer is going to pay for anything. Freon's only $10, so I'll just bill it. I'll just put it on my account. So thanks everyone for joining me during this. As I said before, and as some of you have kind of figured out already, any live stream repairs that I'm going to be doing, that's going to be for my members only, and that's what's going on. Let's see here, HVAC guy. Who we got? There we go. Okay, so yeah, to answer your question, HVAC guy, the issue is the customer was saying that the air is just not getting cold enough, but the fan works fine. The air temps that I'm getting out of my vents right now, they're hovering at about 70 degrees. And this system with an outside temperature should be able to produce 55 degrees. So based on my pressure gauges, I'm going to say that this compressor that's on the car is more than likely some Alibaba refurbished condenser, and the vanes inside of it are junk. I really do not like refurb compressors unless they are from a noteworthy source, and I have never seen one ever since all the plants went to India and China. They really don't care. They put whatever cheap stuff they want in there. So have fun. I'll see you on the next one. I'll try and get some more stuff coming out for you.